For the voltage clamp examples, we connect the model cell via the 10 megohm electrode to the head stage. Set the model cell to ground, mode of operation to VC voltage clamp, and apply a holding potential of plus 100 mV. According to Ohm's law, these 100 mV at the 10 megohm resistance of the electrode result in a 10 nanoampere current. We can see this at the current display. The series resistance compensation in voltage clamp is based on the bridge balance. Therefore, we have to start in current clamp and do the bridge compensation there before switching to voltage clamp. We do this by applying a test pulse as described in the current clamp video. Now we switch to voltage clamp. We apply a pulse of 50 mV, which results in a current pulse of 5 nanoampere. We can adjust the capacity compensation VC potentiometer to get rid of the capacitive transients. Now switch the model cell to cell 1 with 50 megohm. According to Ohm's law, with a 50 megohm cell and a 50 mV pulse, we should expect a current of 1 nanoampere. However, we only have about 0.8 nanoampere. The reason is the series resistance, in this case the additional resistance from the 10 megohm electrode. To compensate this, switch on series resistance compensation and turn up the potentiometer. The theoretical optimum is at about 82% compensation. Overcompensation will increase noise and lead to oscillations.